Hi, today we are going to look at an example of practical problem solving. This was a problem occurred in an embroidery machine which was a deviation of 1500 pieces for the expected target of the day. First of all, we wanted to define the problem. In this case, the expected target of the embroidery machine was 2000 pieces per day, but the current situation was only 500 pieces production, and the deviation of the current situation with the expected target was 1500 pieces. As we all know, the definition of a problem is the deviation of the current situation with the expected situation. After defining the problem, we wanted to find the possible causes with 6M analysis, which also called Ishikawa diagram. Here the methodology is to find possible causes under the main categories which starts from the letter M, which are man, machine, method, material, measurements and mother nature. Our 6M analysis was started with man. In this case, under man we found only machine operator. The machine operator was well experienced and well trained with the machine, and we found no problem with the man. To achieve the expected target, the operational time had to be under 3 minutes, and it was well under 3 minutes. So we found no problem with the method category. Under measurement category also we found no issue, as all the required measurements were achieved perfectly. When we come to the mother nature, it was about the condition of the working area. As the room was air conditioned, we assumed that the mother nature should be okay. There were 3 materials involved with the operation, which were fabric, thread and the double side gum tape. We found no issue with the fabric and the double side gum tape, but there was a downtime reported under thread breaking. We highlighted the issue as a possible cause under the material category. Even under the machine category, only the same thread breaking issue was highlighted. From the initial 6M analysis, it was found that the thread breaking downtime affected for the expected target of the embroidery machine. For further investigation, we wanted more data about the thread breaking downtime. We wanted to find if there is a particular machine head occurred the issue, or the issue is occurred due to the nature of the thread. We introduced a Michel chart to capture those data, and for next 3 hours we captured the data. From the results of the Michel chart after 3 hours, we could find a particular machine head reported more downtime incidents than other 9 machines, which was machine head number 10. Then we had a deep investigation about the machine head 10 with the experts to find the root cause of the issue. The needle fixing method and the threading was perfect in the machine, and the same thread which had been used for other machine heads was used in the particular machine. Therefore, there cannot be an issue even with the thread. Only abnormal thing we could find was 2 sheets of the ceiling were missing. We could find a link between open space of the ceiling and the thread breaking issue when we go for the 5 why analysis. First why was why the thread breaks. The answer was it had melted. The second why was why it had melted. The answer was the needle get heated. The third why was why needle get heated. The answer was because the condition of the surrounding air has gone up. Fourth why was why the heat of the air has gone up. The answer was because the cool which was generated by the air conditioner has gone out from the open space of the ceiling. As a corrected action, The open space of the ceiling was quickly covered with the help of the maintenance team. To check the results of the action taken, we followed up the results for next 3 hours, and there was no thread breaking incident was reported and expected hourly target was achieved. In this way, although we could find the root cause and sorted the problem, we wanted to make action to prevent this kind of issues occurred again. Therefore, we included a new rule into the SOP to check the heat before starting the sewing operation. Thank you for watching this video. See you again.